You look really festive, by the way. That background plus that shirt,
That's awesome.
little white collar, you got it going on.
That's awesome. All right. Welcome everybody out to podcast number 445. We got Mr. Montero here with me again. Say hi, Mr. Montero.
Hello.
We are going to talk about the third section of the book, Elevating Construction Surveyors, where we do an audio recording that will then get transcribed. So stay with us.
This is the Elevate Construction Podcast, delivering remarkable content for workers, leaders, and companies in construction wanting to take their next step. Get ready to step out of your comfort zone with Jason Schroeder as he encourages you to do better, live a remarkable life, and expect more. Let's go.
Welcome, everybody. I hope you're doing well. This is Mr. Montero and me on another podcast. We're doing the third segment where we will go through and talk about the book, Elevating Construction Surveyors. We've already transcribed and gotten the audio onto text for the first sections that we have done. And Mr. Montero here has detailed out at least 20 more sections. So I think we're doing really good here. I think the last one that we had was Learn Civil 3D or CAD, right? And then the next section is Overcoming the Error in Basic Tasks. No, actually, we're in Learn Applied Resection. So let me go ahead and read this. Many trades are using resection to establish setup locations with poor results because neither process nor math are understood. Knowledge of the process should drive your methods, the points you select, and define your tolerances. The more points included, the better your residuals will highlight anomalies. 0.000 is a make-believe residual. You can be an essential training platform as vendors often don't have experience to train, but presently are the ones doing it. So, Mr. Montero, we're going to go back into this and we're going to talk about the story, see if we can get a quote out of this, how we apply it. Really, though, I want to introduce this by saying that why is this important to general surveyors, field engineers, superintendents, owners of companies? You can really do a lot and set up quickly and do some really killer work with resections. And so I'd like you to introduce the concept and what it is first and then get right into a story.
So a resection is where you set up your instrument at a random location. In other words, there's no point underneath it, no rebar, no nail. You're just setting up somewhere where you believe is a good vantage point to perform your work, and you can see a minimum of 3 other control points.
Can you have so what is?
So let me get to the math here really quick. I paused there for a second. And what happens is you'll turn angles to the 3 of those. And shoot distances, and based on the known coordinates of those points, it will triangulate or resect coordinates for the position where you are. And if you have height checked as an option and you're using an instrument height and rod heights, etc., it would even be able to figure out the height of the instrument center from which you're recording your observations.
I'd like you to mention just a little bit, where does this apply? For instance, as a superintendent in my world and former field engineer, I used resectioning a lot for going vertical with buildings and being able to resection on the edge of a deck to either check control, not till it turned 90s. We would usually do that vertically through the sleeves, but to also set blue bangers on decks. So that's the construction world. Can you give us some examples of where you would apply resection in the construction world and in the construction survey world where you live?
Sure. In the construction world, I would say first off that a lot of our vendors, or rather a lot of our trade partners, are already using resection, and they're using it to outline positions such as penetrations to figure out where their utilities are going to go. So you'll see electricians using it for their stub locations, electrical bollards and light poles. You'll see the HVAC guy figuring out where his overhead is going to go in. It's really a pretty common practice. And it's also very commonly done incorrectly, or at least with extremely poor accuracy. In the survey world, or I would say in the civil layout world as well, it's pretty commonly used because a site is busy, and so often the primary control is set around the extremity of the site or the perimeter. But when you're laying out something, or once buildings start going up, structures going up, it's harder to occupy those points on the extremity and shoot things inside the site. So what's really common is to set your total station somewhere where it's convenient, where you can see your work and you can see enough control to perform a resection, locate yourself, and then begin working.
Do you have a story for us that would introduce this?
Well, I have a story of malpractice for resection. I remember being out on a site, and someone had snapped chalk lines down onto the ground, and there was a particular trade partner that was out there, and he was eyeballing with his tape measure where the corner of a column would be by just tape measuring over from the grid lines, eyeballing an intersection for the corner, and then just without marking anything on the ground, just putting his rod at that point and taking a shot. And he did that in two positions. He had an 8'5" rod, so that it was well over his head. And I was really reluctant about the quality of the work that he was about to perform. And he was like, nope, my residuals say 0.000. And he was very confident in the work that he was about to perform. So the issue with the 000, that's what I want to get right into right away, because it's the biggest thorn in my side. When you see a 0 and all zeros residual, that means that there's not really enough data for it to disprove anything. So all it was doing was taking two positions, and then whatever the error in measurement between those two positions, that slop was just going into the calculated coordinates for the instrument. I could say, if you measured a half an inch long from each side, all that would do, if you pulled a tape measure from each side, is add that half of an inch to both of your measurements, and boom, there's the coordinates for your data collector. For your instrument. Doesn't tell you which is wrong, doesn't highlight which might have been a bad observation. It just accepts it and says that everything's perfect. When I say learn applied resection, I'm talking about how do we understand when something is good or when something is bad. So if you incorporate a minimum of 3 points, the first thing that you'll see is that you'll have a residual that's not 0, and you'll be able to see how big your error is. Places where errors can creep into resections, just like everything else, could be the height of a rod. When you're doing any type of control work, the shorter the rod, the better, so that any inaccuracy in your bubble isn't turning into inaccuracy of measurement. So in this case, the trade partner also wasn't really set up on any control. He was just kind of eyeballing positions. It wasn't something that had a predetermined coordinate. He had line work for this wall in AutoCAD. Well, he had line work for the design wall in AutoCAD, not for the as-built wall, which is what he was attempting to create out there in the field. So just tons of little errors creeping into this work. Talking about the 3 points being able to give you some sort of a residual. Well, if you were to incorporate 4 points or 5 points, the more that you had, the easier it would be to determine which one of the observations was bad. So if your residuals were a little bit high and you had 5 points, let's say, well, is there any one residual that stands out, and is the majority of the rest of them really good? Then you can remove that particular observation from your resection and then see what your residuals are. So There are a lot of different ways to perform tight work when performing a resection. And just like any other system of averages, the more information, the better to prove or disprove exactly which point is your outlier.
I like that. One thing real quick I want to interject since I'm turning this into a podcast as well. People can't see this, but I've been in a training all day and I haven't had breakfast or lunch or anything. And so I'm stuffing my face with Doritos on mute while Brendan has to watch me scarf down like a pig on this end and think about how to articulate these sentences. So you are really listening to a pretty professional show here. So he is multitasking Dorito watching and the speech about survey. So great job.
Yeah, I lost my place there for a minute. I was wondering, are those, flaming hot, spicy nacho cheese? Like, what exactly is going on over there?
I'm telling you. Okay, so for resection, we include this in the book for a very specific reason. That surveyors have an opportunity, and field engineers and anybody, to properly use resection, for superintendents to manage trade partners using resection properly, especially when they're laying out components of the building. I'd like you to finish up with a concept and then a challenge for the rest of us, if that's okay.
A concept or a quote is just remembering that the all zeros residuals are make believe. Doesn't exist. My challenge would be to, if you're someone that understands the math or the process behind intelligent applied resection, spread that training around. Right now, the primary way that our trade partners are receiving any training is from our vendors. Our vendors are not surveyors. They're not mathematicians. They're salespersons. They want to get you going as fast as possible, and they may not really understand the math behind the task. So I would say look for those opportunities to spread information around, because the success of any project is something that will be shared throughout all of the trades, all of the different companies who are present on a site. We certainly wouldn't want to watch other people fail when we knew better or when we could assist. So when we see those trade partners using their equipment and attempting to perform a resection, or maybe even asking us, hey, what are the control values? Can I have 2 control points so that I can do a resection? We should be cued right away that this person could use a little bit more additional training and could stand to really find success if we gave it to them.
I love that. One quick thought for me: in construction and on multiple projects as a field engineer and a superintendent, I got into the habit of setting up what I called resection prisms around the perimeter of the project. We would sometimes, even like downtown Los Angeles, when we did the Ambassador High School, do a multi-angular resection, and it wasn't even a distance resection. It was just an angular resection, and use that for the basis of most of the work that we would do for layout and control on the project sites. And it worked very, very well. In doing so, we always solved to a ground point to make sure that we were solving to a known ground point that we knew was precise, and that we could see, hey, does it say move right 0.01 or away 0.025 or whatever, depending on what our prism was. But if it was anything more than what our tolerances were, the inherent error in the instrument, we knew we had a problem. And I just reflect back on the multiple projects. I'm talking like dozens and dozens of projects where I use this to very high levels of success. So I just want to say that I back you up completely on the concept that we have to have this as a mastery. We have to master this concept in construction and in construction surveying. Let's go to number 2. Now, plan your daily tasks. Developing a plan helps you put your tasks in a clear order, tell you what and how and when you need to perform, and allows you to consider the potential variables and roadblocks that may occur. It gives everyone on the team a clear role to prevent doubled or missed processes. This applies to the entire day, from arriving to work through leaving work. Without a plan, it's very difficult to truly measure your success or prevent yourself from going off track. The work order isn't your list of daily tasks. reviewing the work order and performing the work are just items on your daily plan. For many, daily tasks extend after leaving the job site and defining personal goals, family time spent, date night, self-care, and much more. Do you have a story here that you could use to introduce the need for planning your daily tasks, Brandon? While I eat Doritos?
I don't have a story, but I have an example. We talked about that example of not showing up and thinking that you have a position where you can put your brain into coast mode and just exist. Maybe the person who is operating the instrument is doing the thinking for the day, and a rodman is more of a manual labor task. There's nothing like that going on. But what that also means is you can't just show up and let's say, hey, I'm going to show up and I'm going to give my all today. But at what? If your all isn't focused, then it's probably to some extent missing the task, missing the priority, or missing the mark, right? It would be like a water hose just turned on with no nozzle. It's getting everything wet, and when you focus it with a skinny little nozzle, now all of that force is going in one really defined direction. In planning our daily tasks, it's probably something that we should put on paper. Maybe we're using a digital version of that. But we want to make sure that we know where we're going with our entire day. It's not just one task to know, hey, I did or didn't do this task. But what about the time frame? What about how our other tasks for the day fall around that and fill out the way that we're going to use our time? Maybe we have a daily task, but one of them is time sensitive. We have to be back at the office for a certain thing at 12, et cetera. So we really have to understand how our entire day is built. And that means having a plan. And just adding to that, as we read about or talked about just a minute ago, that for a lot of us extends past work and goes home with us, or maybe even in the way that we wake up. Do we wake up with a morning routine? Do we check our emails before we come to work so that we know what to expect throughout the day or who needs to be communicated with? At the end of the day, when we head home, have we created time slots or created intentions for our use of time that have to do with our family? What are we going to do? How are we going to spend that time? Well, again, we can think about it, or we can actually plan it, create time slots, and make sure that those things happen.
I love it. Thank you so much for that section. Okay, I don't have a number here. Let's go to the next one. Learn applied leveling.
Do you want a quote or a challenge?
Oh yeah, let's go ahead. Let's go do a quote or a challenge on that last one.
So my challenge on the last one would be, do you have some sort of a personal organization system already? There are so many different kinds. Some people use their calendar and Outlook. Some people use Microsoft To Do. You'll see people that have built a weekly plan and a daily plan in Excel, and the two reference each other so that as they fill out their weekly plan, it also tells them what they're doing day to day on a different tab. Create for yourself some sort of a daily plan tracking system. There's just so many applications out there that can streamline that for you. And in doing so, you may be able to find out what types of places have you been up until now missing the mark and really achieving what you had planned for yourself. And how could you streamline that or tighten it up by planning differently now that you know what's really going on with your time?
Love that. All right. This is really good content. Learning applied leveling. Transferring elevations from the project benchmark to the site and from the site benchmark around the project supports the building process and brings an additional layer of QC to the job site. Understanding leveling philosophy, leveling math, and instrument setup is an essential component to the backbone of any survey career. Like total station work, leveling has its own field note-taking styles and best practices to make its final product clear and concise. Let's go ahead and take it away.
This is going to be a two-step concept. And so I'll mention that after this is learning level loops. But applied leveling, so this is referring to how do you use your leveling? When do you feel like it's the correct instrument for the task? How quickly are you able to set that instrument up and perform work? In applied leveling, just like with resection, you really do have to understand the math behind what you're doing. And in understanding the math, it should tell you when the QC process is necessary or how you would perform a QC. There's different types of level field notes. Of course, there's single wire. There's 3-wire that allows you to measure distance in your observations as well. Lots of different ways that we might use the level. I'm going to go right into, if it's okay, Jason, while you enjoy that tasty Cool Ranch Dorito. Learning level loops. This one says, was I right? Closure and adjustment of leveling work is what drives its accuracy. It's essential to understand error distribution, how to clearly publish final elevations, and hope to ensure that information is distributed to the team. In addition, your final adjusted values need to be clearly marked and distributed, and anyone who will be using your data or coming off of your benchmarks, to anyone who will be using your data. So how do these two work together? Well, first, in discussing the QC process, a closed level loop is its QC process, right? By going back to our original benchmark, we have the ability to see if we created an error as we came off of the benchmark and went back to our work. By using some styles of leveling, and I always strongly recommend and personally use 3-wire closed level loops. Using 3-wire, its field notes and the math associated with its field notes, you can even see observation to observation if you've created some sort of an error. If there's a poor average between your top and middle line and your middle and bottom line. So there's so many different ways that you can incorporate QC into your work as you're performing it. There are other concepts to leveling like bucking in. Bucking in is where you set up your level at the height of an existing vertically set benchmark. So maybe you've got a target on the wall that's 4 feet above finished floor, or maybe you want to come up, you've got a rod that is, you want to hit a mark that's 4 feet above the existing concrete and dial in immediately to the rod so that you can lay out other targets at that mark. All right, great, but the same principles for applied leveling still apply. If you have a particular distance to the backsite, then you can't be setting targets that are further than that distance as your foresight. Once you've set those foresight points, just like in any other level loop, you would need to kick a leg, reset up at your new target as your backsite, and then foresight your way back to the original and close that loop out to make sure that no error has crept in. So applied leveling means I understand the math, I understand the QC process, and I don't deviate from those things.
I love that. A quick reflection for me for leveling. I once worked with a company where they had what I'll call rampant elevation problems throughout their projects. And it was based on the fact that they weren't using good surveying techniques, good leveling techniques. So a couple of the concepts that you had mentioned, right, using the right datum, going through 2 benchmarks, using 3-wire leveling, estimating to the nearest thousandth, closing your level loops, making sure that we're analyzing that data with great notes. Those are some of the fundamentals. And you and I can both reflect back on many projects where the original survey data or the benchmarks brought in were incorrect. It can be 6 inches, it could be 8 inches. We have experienced large differentials, in my opinion, mostly because of the incorrect use of trigonometric leveling or an improper use of leveling techniques and not using the right instruments. And so for me, this is an incredibly important concept. And if we have surveyors in the industry that are not applying the basics and know the fundamentals and know how to really drive accuracy and precision, you will have a problem. So I would love to know if you have any other concepts that you want to teach with this or a challenge for us.
Well, from a challenge standpoint, I would say being such a big advocate for three-wire level loops, if you think to yourself, well, it's so much faster to do single wire, my challenge would be, well, get faster doing three-wire. Just like when you're figuring out flow and other tasks, who can be doing what at certain times so that no one is waiting. There's the same template that works for three-wire leveling, so that as someone's walking, you're writing, you're doing math. When they're ready for an observation, you're ready. And it shouldn't take you much longer, but it has, it seems like double the QC methods just built right into it. Double the information. Now you have distances available to you. It's really a remarkable way to do things. And so I would say from a challenge standpoint, if you're in that, well, faster is always going to win out, then take an intelligent concept, take something that really can't steer you wrong, and get faster on that concept so that you know that you're set up for success always.
I love that. Fantastic. Okay, let's go to the next one. Learn level loops. Closures and adjustments of leveling work is what
I read that one, and we did a twofer on this last one. I read that one while you were eating your chips.
Well, damn it.
Jason, we're not on today, buddy. I'm screwing up all over the place. I've got all these brain pauses. What's going on?
Oh, that's not a big deal. Okay, number 15. Learn layout basics. Learning to use the equipment itself is one thing. Learning to operate it to perform individual tasks is another. An in-depth understanding of best practice in areas like setting points along a baseline, turning angles to 90, working with your back sight distance, plumb bob, and rod use all come together to create proficiency in layout. Because the tactics used in one type of layout may be different when laying out points for another case use, a well-rounded knowledge base will always serve you. So, Mr. Montero, let's go ahead and talk on this. Learning layout basics.
When I think of layout basics, I think of, as an example, building layout, right? You're turning angles, you're measuring specific distances. There's a lot more that you're doing from a manual level than just allowing the instrument robotically to tell you where things are, or calculated positions at a random angle. You're turning 90s, you're turning 270s. It's really using the instrument itself and getting comfortable with the instrument. It might even include things like making sure that your prism constant is correct. What type of rod is going to support the use of the instrument while you're operating it optically instead of robotically. So getting comfortable with those basics, with the manual use of the total station, or of a conventional total station versus robotic, is always helpful, instead of going straight to operating things robotically and not really understanding the full potential of your piece of equipment.
Do you have a story about the effect of not knowing those basics?
I mean, a good example that I would use is, I'm going to go back to the concept of building layout. When you're using, for instance, a conventional instrument, and you're able to turn a really fine 90 and go ahead and mark that 90, and then flop your instrument and turn the reverse of that and mark it, and then create an average as your true 90. Just doing that helps you understand, what is this instrument capable of? You're actually seeing the capabilities of your instrument reflected physically on the ground in your marks. That's not something that we see when we're operating an instrument robotically. Maybe sometimes when we have the robot double an angle for us, and then we'll occupy that and shoot back, we're just like, well, that wasn't that good. But we haven't fixed the error, and we don't know exactly on which side the error was, which observation. When you do things conventionally, you actually see what this piece of equipment is capable of, and you make the correction right then and there. So I feel like having that experience in performing the basics or in performing work conventionally helps you understand what a total station can even do, when you should expect it to be accurate or not accurate, and how to get around that. And I would just say that, it's really common today with the use of the robot to not even think about those things. We just let it turn its angle. We assume its accuracy, and we move on. And there's no system of double checks or systems of working out the inherent error in our work. We just accept what it gives us and move on. If we're thinking in that don't trust anybody mindset, we can't just accept. We need to QC.
I love that. Okay, so that was let me see how that was. 1, 2, hold on. 1, 2, 3, 4, 5. So that's 5. Okay. So we are going to conclude there with this little podcast, and we'll hit you on the next one when we're going to cover more surveying topics. I hope you've enjoyed this. Brandon, on the count of 3. 1, 2, 3. On we go.
Please join us next time in elevating the entire construction experience for workers, leaders, and companies coast to coast. If you're enjoying the show, please feel free to share with your construction colleagues and help us spread the word by rating, subscribing, and leaving a review on your preferred podcast listening platform. We really appreciate it. We'll catch you next time on the Elevate Construction Podcast.